Surviving a trip to Venus would push the boundaries of human endurance. No ordinary spacesuit could withstand the planet's unforgiving conditions. In 1982, the Soviet Venera 13 probe achieved what seemed impossible, landing on the most hostile planet in our solar system. It sent back haunting images before succumbing to the brutal environment. This video is a signal, broadcasting across our own planet before it ever reaches the stars. I want to map where this signal is being received right now. Let me know in the comments from where you are watching. Picture a world where every element is designed to kill. The atmosphere behaves more like a liquid than air, dense with carbon dioxide and sulfuric acid. Temperatures soar to 475 degrees C, hot enough to melt lead instantly. A specialized suit crafted from titanium, gold, and acid-resistant alloys would be your only lifeline. As you touch down, the ground would crack beneath your feet. Dark, jagged rocks stretch across endless lava plains. The sunlight appears strange, a pale disk barely visible through thick, toxic clouds. Sound becomes distorted, your own breathing feeling distant and muffled. The pressure here is 90 times greater than Earth's, lethal beyond comprehension. Without protection, death would be instantaneous. Your body would collapse in less than a second. Lungs would implode, ribs would cave, and blood vessels would burst before your brain could register the catastrophic failure. Even with an advanced suit, survival would be temporary. Sulfuric acid rain falls in slow motion, hissing as it evaporates against your visor. The gold coating begins to dull. Heat creeps through your protective layers. The environment feels absolutely lifeless. No wind, no motion, just a soft hum of oxygen and distant mechanical groans. This is Venus, a planet that transforms any notion of hospitable environment into a nightmare of pure, unrelenting hostility. Snen, your suit fights against the crushing pressure, each moment a battle for survival. Minutes pass and the cooling system begins to fail. The special liquid keeping you alive starts to boil, temperatures climbing rapidly inside the protective shell. Breathing becomes difficult. Air thickens, each inhale heavier than the last. Your pulse races, heartbeats thundering in your ears. Sweat vanishes instantly, leaving skin dry and burning. Warning signals flash across your display, coolant pressure dropping, core temperature rising. Heat seeps deeper, feeling like a furnace's breath against your arms and chest. Your legs weaken with each step, movements growing slower. 10 minutes in, acid rain has eaten through the suit's outer coatings. Titanium armor bears scars, small chemical vapor jets hissing from its joints. The temperature surpasses 80 degrees C, beyond human endurance. Breathing turns shallow, vision blurring as heat stroke takes hold. You struggle to remain upright, but gravity and exhaustion pull you down. Collapsing on the glowing rock, your body trapped in a metal shell that begins to soften under immense pressure. Acid works quickly now, eating through visor cracks as systems shut down one by one. Seconds pass and the suit folds in on itself. Crushing weight and unbearable heat complete the destructive work. Nothing remains, just a small crater of scorched metal and rising vapor wisps. Venus claims another visitor, as it always does. This isn't just the hottest world we know, but a living furnace designed to erase anything daring to exist upon it. Not every planet destroys with fire. Some kill with silence, with cold, with light so harsh it burns without flame. A small, scarred planet of endless extremes. One side frozen in eternal night, the other burning beneath a never-ending dawn. Leaving Venus's burning clouds, you travel closer to the Sun and Mercury, the smallest and innermost planet in our solar system. Here, light and darkness are eternal enemies. One side scorched by sunlight hot enough to melt metal, the other lying in shadows so deep that ice survives untouched for billions of years. Mercury has almost no atmosphere, just a thin exosphere of atoms blasted off its surface by solar wind. No air to breathe, no wind to carry sound. And the Sun dominates everything on Mercury, filling the sky 3 times larger than it appears from Earth and flooding the surface with light more intense than anywhere else in the solar system. Within moments, the vacuum would kill you without a protective suit. Your blood would boil, your skin would crack from the lack of pressure, and solar radiation would burn through your cells. Landing near Mercury's equator, where the dividing line between night and day runs like a scar, you'd find absolute silence. No air carries sound, only the dull crunch of dust beneath your boots as you step onto a world unchanged for billions of years. Grey rock and dust cover the surface, littered with craters and long cliffs called Lobat scarps, created as the planet's crust shrank while cooling. Mercury's interior is mostly iron, with over 60% of its mass being metallic. This gives it a massive core and a surprisingly strong magnetic field for such a small planet. Initially, the cold dominates. The nightside temperature drops to -170 degrees C, colder than any place on Earth. Water ice remains trapped inside permanently shadowed craters near the poles. Walking across the frozen surface beneath a black sky filled with motionless stars, you witness a strange planetary day. Mercury rotates slowly, taking 59 Earth days to complete one spin, while its year lasts only 88 days. One day from sunrise to sunrise spans 176 Earth days. The result is a world where the sun crawls across the sky in slow motion, baking the ground for weeks without rest. As the first rays touch your visor, the brightness becomes blinding. White and harsh, pure sunlight without air to soften it. Temperature rises almost immediately, 100 degrees C, then 200 degrees, and soon over 400 degrees as rocks start to shimmer. With no atmosphere to carry heat, only sun-facing surfaces burn while the rest remains freezing. The temperature difference between day and night can reach over 600 degrees, the largest swing in the solar system. Mercury's thin magnetic field offers almost no protection from the solar wind. Charged particles from the sun strike the surface directly, knocking atoms into space and leaving behind a harsh, unforgiving landscape. The sun fills the sky like a white flame, a blinding force that turns the world into a blur. On Mercury, once you step into daylight, there's no escape. Your visor darkens, but the glare seeps through, overwhelming your senses. Temperatures outside soar to 427 degrees, and radiation levels climb rapidly. The fluid in your cooling lines begins to boil, and suit systems strain against the intense solar energy. Your heartbeat quickens as the heat pushes through the suit's outer layers, cooking you slowly from the outside in. Electronics start to fail. Cooling fans fall silent. The air inside your helmet grows thick and hot, with every breath becoming heavier than the last. Within minutes, systems collapse, suit seals warp and buckle, and intense radiation burns through the final layers. Your muscles weaken and vision fades as your body overheats. When it's over, nothing remains. No smoke, no ash, just the shimmering horizon and the faint echo of solar wind sweeping across the barren surface. This is Mercury, a world of perfect extremes, no air, no water, and no mercy. Yet, Despite its lifelessness, Mercury is more than a planet of fire and ice. It's a frozen fragment of time, orbiting closest to the light that created it. Its heavily cratered surface preserves the scars of cosmic history, while its massive iron core tells scientists how planets form and evolve near their stars. From Mercury, you travel outward to another world that has long captured human imagination: Mars. From orbit, it appears peaceful, a desert world of crimson plains, carved valleys, and soft orange skies. But beneath that beauty lies a place that will kill an unprotected human in moments. Unlike Mercury or Venus, Mars offers a faint promise. This world might someday be conquered, not by machines, but by people. A small, cold planet that looks almost like home, yet is far more dangerous. During the day, Mercury's temperatures reach 427 degrees arcs. At night, they plunge below 70 degrees. Even the strongest machine could survive here for only a short time. And thus, you step onto the Martian surface near the equator, a region NASA's rovers once explored. Your pressurized suit protects you from the harsh environment. The ground beneath your boots crunches softly, a mix of fine red dust and volcanic rock fragments. The landscape resembles a desert on Earth, silent under a pale orange sky. Gravity here is only 38% of Earth's, making each step carry you farther. The sunlight looks dim and reddish, filtered through thin layers of dust. In the far distance, Olympus Mons rises, the largest volcano in the solar system, towering 3 times higher than Mount Everest. To the east, the ground drops dramatically into Valles Marineris, a canyon stretching 4,000 kilometers long, wide enough to encompass the entire continental United States. At midday, the temperature hovers around 20 degrees C, but when night falls, it plummets below 70 degrees. The thin atmosphere can't retain heat, causing dramatic temperature swings that can reach nearly 90 degrees. Even when sunlight feels warm, the air remains bitterly cold. Billions of years ago, Mars was radically different. Rivers carved canyons, and lakes filled ancient craters. Scientists have discovered minerals that only form in water, suggesting Mars once had a thicker atmosphere and a magnetic field strong enough to protect it. When that field collapsed, the solar wind stripped away the atmosphere, leaving behind this cold, airless desert. Dust continues to shape the planet. Weak winds lift fine iron oxide grains, the same mineral giving Mars its red color. Sometimes, these winds escalate into enormous global dust storms that can block sunlight for months. Though the wind seems light, the dust is treacherous. It contains toxic perchlorates that would burn skin and lungs upon exposure. Radiation poses another silent threat. With no magnetic field and only a thin veil of carbon dioxide for protection, solar particles and cosmic rays constantly strike the surface. Long-term survival seems nearly impossible without thick shielding. The atmosphere is 100 times thinner than Earth's, composed mostly of carbon dioxide with almost no oxygen. In this environment, you wouldn't suffocate slowly. Instead, you'd black out in less than 30 seconds as your blood begins to boil and your body swells in the near vacuum. As the day fades, you look up at the pale sky, the sun appearing smaller than on Earth, casting long shadows across the desolate landscape. Anon, the red plains, silence surrounds you. A faint warning light flickers, signaling trouble. The horizon glows as Phobos rises, racing overhead in just 4 hours. Temperature plummets rapidly to 60 degrees C and beyond. Frost forms on your visor, while your breath fogs the glass. For a moment, everything feels peaceful. Beneath your feet, frozen soil might still hide flowing water, as secret scientists discovered in 2018 when they detected a potential subglacial lake beneath Mars's south pole. But the cold closes in relentlessly. Your suit's heater strains against the freezing air. Dust clings to your armor, wearing down the seals. Pressure drops. You attempt to patch the breach, but materials have become too brittle in the extreme cold. Your oxygen supply dwindles. Falling to your knees on the red sand, you watch the horizon fade into darkness. Stars return to a soundless sky. Within minutes, your body freezes solid, perfectly preserved by this planet that once tempted with warmth and possibility. Survival here is brutal. With full protection, you might last 8 hours. Without it, merely 2 minutes. Mars remains silent, cold, utterly indifferent. A frozen memory of what Earth could become if stripped of its atmosphere. Yet, it feels special. The only other world where humans might someday walk, build, and stay. Every mission is a rehearsal for that future. Leaving Mars behind, you approach Jupiter, a planet so vast it could swallow all others and still have space to spare. 11 times wider than Earth, 2.5 times more massive than all other planets combined, large enough to contain 1,321 Earths. From a distance, Jupiter looks calm and beautiful. Golden bands stretch across its surface, crowned by the massive Great Red Spot, a storm raging for at least 350 years, spanning over 16,000 kilometers. But beneath those swirling clouds lies an atmosphere of unimaginable violence. Jupiter has no solid surface. What we perceive as its surface is merely the top of an atmosphere composed of 90% hydrogen and 10% helium. Gravity pulls you downward at 2.5 times Earth's strength. Winds exceed 600 km/h. Light itself behaves differently, scattered through ammonia and methane haze that transforms the planet's clouds into endless ribbons of white, orange, and complexity. If you dropped down into Jupiter's atmosphere, death would arrive swiftly. But the descent would be extraordinary. Far above the cloud layers, temperatures hover around 45 degrees C, with pressure matching Earth's sea level. Sunlight reflects off ammonia ice clouds, creating a marble-like surface that spacecraft like Voyager, Cassini, and Juno have captured in stunning images. Deeper into the planet, conditions transform dramatically. Sunlight vanishes, while air density increases. Pressure doubles, then triples. Temperatures climb above -100 degrees, and clouds shift to darker hues. Around 50 kilometers down, ammonium hydrified layers emerge, filled with sulfurous toxic clouds. Hurricane-speed winds tear the atmosphere into massive belts, circling in opposite directions. Beneath these winds, lightning dominates the landscape. Bolts hundreds of times more powerful than Earth's strike, through water and hydrogen clouds. Each electrical discharge generates enough energy to power an entire city. Thunder becomes a constant companion, driven by Jupiter's immense internal heat, which radiates 1.6 times more energy than solar radiation. At 100 kilometers deep, conditions become extreme. Pressure reaches 10 times Earth's standard, and temperatures rise past 0 degrees C. The air transforms, behaving more like a liquid than a gas. NASA's Galileo probe explored this realm in 1995, surviving 58 minutes before being crushed, transmitting crucial data until its final moment. Continuing downward, hydrogen undergoes radical changes. By 150 kilometers, pressure increases to 20 times Earth's level, with temperatures climbing to 150 degrees C. The gas transitions into a supercritical fluid, neither fully liquid nor gas, flowing without clear boundaries. What was once a descent through Air becomes a journey through a shimmering hydrogen and helium sea. The pressure increases exponentially with each passing minute. At 200 kilometers, temperatures exceed 500 degrees C, and pressure reaches 100 atmospheres. Metals soften, electronics fail, and even the most robust protective gear collapses under immense force. Hypothetically, further descent would compress hydrogen into a metallic state, a vast liquid metal ocean conducting electricity. Scientists theorize this metallic hydrogen generates Jupiter's magnetic field, which towers 20,000 times stronger than Earth's and extends millions of kilometers into space. This powerful field traps deadly radiation, forming protective belts that shield the planet's interior. Unfortunately, Jupiter is a cosmic force of unimaginable destruction. Any spacecraft attempting to enter its atmosphere would be obliterated within hours. At its core, temperatures soar to around 20,000 degrees C, with pressures millions of times greater than Earth's. Scientists believe a rocky, metallic core about Earth's size exists, surrounded by hundreds of thousands of kilometers of metallic hydrogen. No probe could ever survive such conditions. Diamond would melt long before approaching close. The descent doesn't end with impact, but with total annihilation. Anything entering would be crushed, burned, and vaporized before reaching any solid ground. From the moment of entry, survival would last less than 3 minutes. Yet, Jupiter is more than just a destroyer. Its massive gravity acts as a cosmic shield, deflecting comets and asteroids that might otherwise strike the inner planets. Without Jupiter, Earth could have been bombarded to extinction long ago. In this way, Jupiter embodies both guardian and executioner, the very reason life exists on Earth and why it could never exist on Jupiter itself. Leaving these violent storms behind, you descend toward Europa, one of Jupiter's most enigmatic moons. Europa appears deceptively simple. From space, it glows like marble, its smooth surface stretched with kilometers-long cracks. It seems still and lifeless. Yet beneath its frozen crust lies an ocean larger than all of Earth's oceans combined. This small world, only 300 kilotons wide and slightly smaller than our moon, is almost entirely composed of water ice, frozen solid at temperatures near 160 degrees. The ice reflects sunlight so efficiently that Europa is among the brightest bodies in the solar system. Dark lines etched across its surface are caused by tidal forces. Jupiter's immense gravity stretches and flexes the moon, generating heat that prevents its buried ocean from freezing completely. Landing here would mean absolute silence. Jupiter dominates the black sky, appearing 25 times larger than the moon looks from Earth. There's no breathable atmosphere, only a faint trace of oxygen too thin to support life. Without protection, you'd suffocate in seconds, your body freezing solid before touching the ground. Even in a full protective suit, Europa remains deadly. Jupiter's magnetic field bombards the moon with radiation up to 400 millisieverts per day, enough to kill a human within 24 hours. The ground itself is treacherous, jagged and fractured, formed by ice slabs that have broken, shifted, and refrozen countless times. Beneath this crust lies a mystery waiting to be understood. And beneath the ice of Europa, a frozen moon of Jupiter, lies a dark secret. An ocean, possibly 100 kilometers deep, warmed by heat from the rocky mantle. Walking across its surface, you'd feel the ice cracking softly under your feet, flexing with the moon's subtle movements. Faint tremors ripple across the frozen landscape every few minutes. Sudden vapor columns burst upward, shooting water plumes between 100 and 200 kilometers into space. These eruptions, first spotted by the Hubble Space Telescope and later confirmed by missions like Galileo and the upcoming Europa Clipper, might carry ocean samples from far below. Any approach would instantly transform the vapor into frost-forming ice crystals, coating your suit. The weak sunlight, 25 times dimmer than Earth's, provides no warmth. Cold penetrates even the thickest insulation. Within an hour, radiation degrades your electronics. Oxygen dwindles, vision flickers as shielding fails. You collapse onto the ice. Jupiter's glow reflects faintly across frozen cracks. Seconds later, your body freezes solid, perfectly preserved in Europa's endless winter. Yet, something extraordinary exists beneath this hostile surface. An ocean of liquid water, mixed with salts and minerals, potentially warmed by hydrothermal vents. Such environments on Earth support thriving microbial ecosystems that survive without sunlight, sustaining themselves through chemical processes alone. Scientists believe Europa could harbour similar life. The Europa Clipper mission will soon fly through these plumes, analysing their chemistry for organic molecules, potential life signatures. If life exists here, it would demonstrate that biology requires only water, energy, and time, not necessarily warmth or sunlight. Europa would swiftly kill a human, yet something might already be alive in its depths. Ancient, hidden, and awaiting discovery beneath a frozen sea. From this captivating world, humanity's gaze turns to another planetary marvel, Saturn, the golden giant. From a distance, Saturn appears serene and ethereal, a world wrapped in light, encircled by a glimmering halo of ice and stone. But this seemingly calm exterior masks a fierce, unforgiving planetary environment. As the solar system's second largest planet, Saturn spans 120,000 kilometers, nearly 10 times Earth's width. Composed predominantly of hydrogen, 96%, and helium, 3%. It represents a massive, swirling gas giant of remarkable complexity. Here's the rewritten text. Saturn appears delicate from a distance, but this celestial giant harbours an interior of extreme conditions. Its density is remarkably low, so light that it would float if placed in a large enough ocean. The planet's atmosphere is a complex canvas of colours and movement. From orbit, it looks like a masterpiece painted in golden ivory. Thin layers of ammonia crystals scatter sunlight into soft pastel bands, while deeper atmospheric zones contain ammonium hydrosulfide and water vapour that create subtle yellow and brown tones. Seemingly peaceful from space, Saturn's environment is anything but calm. Winds scream across its atmosphere at 1,800 km/h, more than 4 times faster than Earth's most violent hurricanes. A descent into this world begins deceptively gently. Thin, glittering clouds drift in slow motion, and initial temperatures hover around 175 degrees C. But this tranquility quickly shatters. Pressure builds, temperatures rise, and sunlight fades as the gaseous environment thickens. Lightning flashes illuminate massive storms that stretch tens of thousands of kilometers, so intense they're visible from Earth through telescopes. Around 100 km beneath visible clouds, the pressure matches Earth's deepest ocean trenches. Temperatures climb above 0 degrees C, and hydrogen and helium begin behaving like liquid. You're now falling through a bizarre gaseous ocean without surface or shore. Deeper descent reveals increasing hostility. At 200 kilometers down, temperatures soar to 1,000 degrees C, and pressure becomes hundreds of times greater than Earth's sea level. The surrounding gas glows faintly, heated by Saturn's internal energy, generated as the planet slowly contracts under its immense gravity. Here, hydrogen undergoes a remarkable transformation, becoming metallic hydrogen, an exotic material conducting electricity and helping generate Saturn's magnetic field. Though weaker than Jupiter's, this field still extends millions of kilometers into space. Scientists theorize that beneath these metallic oceans lies a dense core of rock and metal, potentially 15 times heavier than Earth, and surrounded by compressed hydrogen. However, no human or machine could ever penetrate this deep. Within just 5 minutes of atmospheric entry, crushing pressure and extreme conditions would destroy any probe. Saturn is a world of extremes, where even the strongest metals would crumble long before reaching its lower layers. Yet amid this destruction, its beauty remains overwhelming. The planet's ring system stretches an incredible 280,000 kilometers, forming one of the most spectacular structures in our solar system. Made mostly of ice particles ranging from dust-like specks to mountain-sized chunks, these rings orbit at incredible speeds, their intricate patterns sculpted by nearby moon gravities. Scientists believe these rings emerged around 100 million years ago, when a moon or comet drifted too close and was torn apart by Saturn's gravitational forces. The result is a shimmering disk that transforms destruction into breathtaking beauty. At the North Pole, another marvel spins endlessly, a massive hexagonal storm. This geometric wonder measures 30,000 kilometers across and over 100 kilometers deep, locked in place by powerful jet streams. It has persisted for decades, perhaps centuries, rotating with perfect symmetry. When sunlight strikes it, the storm glows in mesmerizing blues and golds, creating an aurora visible from millions of kilometers away. Descent into Saturn becomes increasingly hostile. Golden clouds darken until no light remains. Temperature and pressure rise beyond survivability, crushing everything in their path. Within moments, any visitor would be compressed, vaporized, and scattered into the endless hydrogen atmosphere, just another microscopic particle in Saturn's vast cosmic sea. Yet Saturn's story doesn't end with its turbulent atmosphere. Orbiting the planet are dozens of moons, with one standing dramatically apart, Titan. This extraordinary moon is unique in our solar system, boasting a thick atmosphere, surface rivers and lakes, and a chemistry remarkably similar to early Earth billions of years ago. From orbit, Titan appears as a muted orange sphere, shrouded in a dense, obscuring haze. Beneath this veil lies a landscape of mountains, dunes, and glacial plains carved not by water, but by liquid methane and ethane. At 550 kilometers in diameter, Titan represents a world of profound mystery and potential. Titan looms large, bigger than Mercury, its surface a complex landscape of organic chemistry. As you descend through the golden haze, sunlight fades to a dim orange glow, revealing a world both alien and strangely familiar. The atmosphere is primarily nitrogen, about 95%, with traces of methane and complex hydrocarbons. Pressure here is 1.5 times Earth's, making the air feel heavy against your suit. Yet, it's a toxic mix that would kill instantly. One unprotected breath means certain death. Holin particles drift through the upper atmosphere, created when sunlight breaks apart and recombines methane molecules. These dark, heavy compounds fall like smog, giving Titan its distinctive amber color. Temperatures plummet to around 118, cold enough to freeze carbon dioxide into rock-hard ice. Visibility improves as you near the surface. Vast landscapes unfold, wide river valleys, frozen plains, and enormous dunes stretching hundreds of kilometers. These dunes, composed of solid hydrocarbon grains, are shaped by weak but constant winds over millions of years. Near a polar region, sunlight filters through mist like perpetual twilight. The ground is frozen solid, covered in methane frost. A gleam catches your eye. Walking closer, boots crunching on icy terrain, you reach the edge of a lake, but not a water lake. This surface ripples with liquid methane and ethane, hydrocarbons that exist as gases on Earth but flow freely here due to extreme cold. Some lakes span hundreds of kilometers, surrounded by channels carved by methane rain. Touch it, and your glove would instantly freeze. The liquid is colder than dry ice, shattering anything it contacts. Despite the freezing conditions, Titan offers surreal experiences. Gravity is just 14% of Earth's, allowing easy, slow-motion movement. The dense atmosphere means small wing attachments could enable human flight. A person gliding through an alien sky. Your suit's heaters work overtime, struggling to maintain a stable temperature. The air is thick and heavy. The landscape is shrouded in golden mist. The sun appears as a faint, distant star in this otherworldly environment. The harsh landscape of Titan stretches out, a world of extreme conditions where survival seems impossible. Beneath your feet, the ground is a rigid crust of frozen water and hydrocarbons as hard as granite. Scientists theorize a hidden subsurface ocean of liquid water and ammonia lurks below, potentially harboring the fundamental chemistry of life. Your survival here would be brief and unforgiving. Within hours, the intense cold would begin to compromise your suit systems. Joints would stiffen, seals would fail, and oxygen would condense into liquid. Hypothermia would set in, and the methane winds would quickly erase any trace of your presence. Despite these challenges, Titan remains a beacon of scientific intrigue. Its thick atmosphere provides radiation protection, and vast methane and organic compound reserves could someday fuel human exploration. NASA's upcoming Dragonfly mission, a nuclear-powered drone set to launch in the mid-2030s, will investigate the Moon's dunes and icy plains, searching for chemical precursors of life similar to those that emerged on young Earth. You might survive here for roughly 2.5 hours before succumbing to the environment. In that brief window, you'd witness an alien world strangely reminiscent of Earth. Rivers, rain, and clouds following a methane cycle, a frozen snapshot of our planet's distant past. Beyond Titan, the solar system grows increasingly alien. The sun diminishes to a distant faint spark. The next destination is Uranus, a pale, ice-covered world tilted dramatically on its axis. Unlike any other planet, Uranus spins sideways, with its poles where its equator should be, likely the result of a massive collision billions of years ago. This extraordinary tilt creates bizarre planetary dynamics. Each pole experiences 42 consecutive years of darkness or light, a testament to the violent cosmic events that can reshape entire worlds. Uranus stands as a reminder of the solar system's chaotic and unpredictable nature, a blue-green sphere hanging in the void, glowing softly like an enormous piece of glass. Uranus appears deceptively calm from a distance, its smooth surface shrouded in a hazy blue atmosphere. This tranquil exterior masks a world of extreme violence and strange phenomena. The planet's atmosphere consists primarily of hydrogen, 83%, and helium, 15%. With about 2% methane, giving it a distinctive turquoise color by absorbing red light. Unlike rocky planets, Uranus is a gas giant, or more accurately, an ice giant, with no solid ground to land on. surface is merely a thin veil of gas concealing a deep, murky ocean of superheated ices under immense pressure. Faint rings of dark dust and icy fragments, discovered in 1977, circle the planet, almost invisibly. The planet holds the record for the coldest temperatures in our solar system. Upper clouds composed of methane ice crystals hover around 220 degrees. Descending through its atmosphere reveals increasingly harsh conditions. Sunlight fades to a ghostly green, scattered by methane haze. Temperatures plummet to 224 degrees, colder than liquid nitrogen, challenging any spacecraft's heating systems. Beneath its seemingly quiet exterior, Uranus harbours brutal winds reaching 900 km/h, moving in the opposite direction of the planet's rotation. Atmospheric pressure intensifies, rising to 10 times that of Earth. Hydrogen sulfide becomes prevalent, creating an environment instantly lethal to unprotected life. The planet's magnetic field adds another layer of complexity. Tilted 60 degrees from its axis and offset from the planet's center, it creates chaotic radiation belts that fluctuate unpredictably. Any spacecraft entering this field would face intense electrical surges and deadly particle storms. As you descend deeper, pressure continues to climb, reaching hundreds of times Earth's atmospheric pressure. The hydrogen and helium environment becomes increasingly dense and hostile, transforming from gas to something more akin to a fluid state under extreme conditions. This continuous daylight, followed by 42 years of darkness, only adds to Uranus's otherworldly nature, a planet of extremes, beauty, and unimaginable violence. As temperatures rise to 1000 degrees C, Uranus undergoes a dramatic interior transformation. Water, methane, and ammonia compress into a dense hot ice, a unique state of matter that behaves like both solid and fluid simultaneously. Some scientists propose an extraordinary possibility. Deep within this region, diamonds might form. Under extreme pressure, methane molecules split apart, with carbon atoms crystallizing into solid diamonds that rain downward, potentially creating vast diamond oceans or layers around the planet's core. It's a mesmerizing concept, a world where gemstones literally fall from the sky. Yet, no probe has ever ventured deep enough to confirm this theory. The descent becomes increasingly chaotic. Winds howl. Pressure intensifies, crushing any spacecraft while internal friction converts motion into intense heat. Sensory systems would fail rapidly, one by one. Uranus's deeper layers remain completely unexplored. Even the most advanced spacecraft would survive mere minutes before disintegrating under immense gravitational forces. Within 3 to 5 minutes of atmospheric entry, everything would be destroyed, frozen, crushed, and vaporized in a silent blue abyss. From space, Uranus appears in quiet perfection. Its pale glow remains unchanged, with storms invisible beneath a seemingly calm exterior. The planet hosts 27 known moons, each named after characters from Shakespeare and Alexander Pope. Titania and Oberon, its largest moons, are worlds of ice and rock, potentially concealing small oceans beneath their rocky surfaces. Beyond Uranus, the solar system dissolves into true darkness. The sun becomes a distant, faint spark, so weak that daylight here is barely brighter than Earth's twilight. Drifting in this dim light is Neptune, the 8th planet and the last major world before interstellar space begins. Neptune represents the most remote, mysterious, and violent of the great planetary giants. Cobalt blue clouds and roaring winds define its landscape, with storms larger than Earth sweeping silently across its sky. Despite being nearly 4.5 billion kilometers from the Sun, Neptune's atmosphere churns with incredible energy, driven by internal heat rather than sunlight. The planet emits nearly 2.6 times more energy than it receives, a paradoxical frozen world burning from within. Roughly the same size as Uranus, at about 50,000 kilometers in diameter, Neptune is slightly denser and far more dynamic. Its atmosphere consists primarily of hydrogen, helium, and methane, with the latter providing its deep sapphire color. Nuanced beneath Neptune's serene blue exterior lurks an atmosphere of unimaginable violence. Winds tear through space at 2100 km/h, making this planet's atmosphere the most turbulent in our solar system. As you approach, a blue sphere grows larger, all its beauty masking incredible chaos. Faint rings hover almost invisibly around the planet. White clouds swirl across vast distances, creating massive storm systems. The legendary Great Dark Spot, first discovered by Voyager 2 in 1989, represents just one example of Neptune's dynamic nature. Massive vortexes appear and vanish like living breaths, constantly reshaping the planetary landscape. Descending begins in bitter cold. The upper atmosphere plummets to 220 degrees C, far colder than dry ice. Weak sunlight filters through methane haze, casting soft blue tones. Thin clouds of methane ice crystals drift through winds faster than sound. Pressure changes rapidly. Near the surface, it matches Earth's sea level, then rises exponentially. Deeper within, temperatures climb dramatically. The atmosphere transforms into a supercritical fluid, neither liquid nor gas, but something in between. Lightning erupts through darkness, hundreds of times more powerful than Earth's electrical storms. These bolts would illuminate clouds of methane and hydrogen, though no sound could travel through such rarefied conditions. Continuing downward, the environment becomes increasingly extreme. Pressure crushes everything, reaching hundreds of atmospheres. Temperatures surge past 1000 degrees C, causing hydrogen, helium, water, and methane to blend into strange compressed forms. Beneath this turbulent layer, a vast ocean of superheated water, ammonia, and methane exists. At unimaginable depths, carbon crystallizes into diamond rain. These glittering storms fall toward Neptune's core through an environment of unparalleled intensity. Pressure exceeds 1 million times Earth's, with temperatures approaching 7,000 degrees C, nearly as hot as the sun's surface. Somewhere in this maelstrom, a rocky core potentially twice Earth's mass awaits, hidden from direct observation. Dan Earth, surrounded by oceans of exotic matter. But long before any visual confirmation, a journey toward Neptune reveals a stark reality. The sun's distant light offers no comfort here. Crushing force and heat would vaporize everything in moments. Your ship has less than 2 minutes before imploding. The atmosphere folds inward and you vanish into Neptune's abyss. From above, the planet appears serene, its brilliant blue clouds turning slowly in silence, storms drifting endlessly across a world without surface or sound. Beyond Neptune lies the frozen frontier, a realm of dwarf planets, icy debris, and the cold breath of interstellar space. At this edge orbits a small, lonely world, colder than any other. Travel farther into the deep twilight of the solar system, where sunlight takes more than 5 hours to arrive and appears as nothing more than a brilliant star in a black sky. Here drifts Pluto, the frozen heart of our solar system. Just 2,376 kilometers wide and smaller than Earth's moon, it's one of the most complex objects ever explored. In 2015, NASA's New Horizons spacecraft revealed a landscape far more varied than imagined. Plains of frozen nitrogen, towering water ice mountains and a thin atmosphere that expands and collapses with changing seasons. From a distance, Pluto looks pale and calm, a patchwork of white, brown, and pink. Its most striking feature is a vast heart-shaped region named Tumbor Regio, discovered in 1930. One side is Sputnik Planitia, a frozen nitrogen sea smoother than glass and wider than Texas. The opposite side is rough and mountainous, with water ice peaks standing 3,000 meters tall. Descending through its faint atmosphere, mostly nitrogen with traces of methane and carbon monoxide, you'd encounter an environment 100,000 times less dense than Earth's air. Unprotected, you'd lose consciousness instantly as the vacuum boils skin moisture. Temperatures plummet to minus 230 degrees, instantly freezing any exposed body. Only with full protection can one touch down on these frozen, silent plains where weak sunlight barely penetrates the endless darkness. The horizon glows faintly through a thin haze, scattering blue light against the darkness of space. Sunlight, barely bright enough to cast a shadow, reveals a landscape of frozen nitrogen. Beneath your boots, the ground is brittle as glass, creaking with each step that echoes in profound silence. Pluto's surface is a living canvas, constantly reshaping itself. Sputnik Planitia, the great frozen plain, undergoes perpetual transformation. Nitrogen ice dances between states, evaporating in sunlight and refreezing at night, erasing craters and creating intricate hexagonal ridges. This continuous motion suggests hidden thermal activity, possibly from radioactive decay deep within Pluto's core. Scientists speculate about a potential subsurface ocean of liquid water mixed with ammonia, still unfrozen despite the extreme cold. Charon, Pluto's largest moon, looms motionless in the sky, locked in a mutual tidal embrace. Nearly half Pluto's size, this companion world bears scars of canyons and dark plains that seem carved from shadow. As the horizon begins to fade, temperature plummets to minus 233 degrees Celsius, colder than anywhere on Earth by over 200 degrees. Your suit systems struggle against the invasive cold. Heaters run at full capacity, but the chill creeps through every joint and layer. Oxygen condenses inside pipes while electronics flicker uncertainly. The distant sun gleams faintly over the icy horizon, a soft blue haze glowing against infinite blackness. This is where warmth ends, where day and night blur into an endless frost. Minutes later, systems fail. Heaters die, oxygen feed freezes solid, and cold seeps in faster than reaction is possible. Gravity here is only 6% of Earth's before vanishing completely. Within seconds, your body becomes another frozen monument on Pluto's eternal plains. 1,000 years later, you would remain perfectly preserved, as if time itself had stopped. Pluto would claim your life in less than 10 minutes, yet it remains one of the most hauntingly beautiful worlds ever discovered, a frozen relic of the solar system's birth, still holding traces of mysterious activity. And beyond Pluto lies a vast sea of icy fragments known as the Kuiper Belt, stretching into darkness where comets slumber and the sun fades to a distant memory. This is where the solar system begins to dissolve into the endless cold of interstellar space. Here, at the frozen frontier, distance becomes the only measure. No days or nights exist, just an infinite quiet edge of everything we've ever known. From the infernal heat of Venus to the frozen stillness of Pluto, death wears different faces across these worlds, crushed by pressure, burned by radiation, frozen in silence, or dissolved in storms. Every world reminds us how fragile life truly is. Yet, within that fragility lies something extraordinary. On a single small planet, circling an ordinary star, life not only survived, but learned to look outward, to wonder, to explore, and to dream of reaching these distant, hostile environments. The planets we've visited are merciless, but beautiful. Each is a piece of the story that shaped us. Their extremes teach us about our own limits. Their silence gives meaning to our noise. Their endless night makes our daylight precious. Beyond the sun's warmth, untold mysteries await. Oceans hidden beneath ice, diamonds falling through clouds, storms that never end. And somewhere, perhaps, the same spark that lit our world could be waiting in another. This journey isn't about how we die on other worlds. It's about why we keep reaching for them. Because even in the silence between the stars, curiosity refuses to die. Hey, I really appreciate your support. Hitting the subscribe button and giving the video a like means the world to me. These small actions help the channel expand and reach more people.